A warm welcome to this conclusive session of this massive open online course on wavelets and multirate signal processing. In this we will have a quick conclusion and looking ahead on what we would do in a subsequent larger massive open online course, by first requesting all my young friends here, my teaching associates who have helped me create this material. So, I am going to ask them to take just a minute each and summarize what they learnt in the specific lectures that they dealt with. So, let me begin with Jayavardhan. Jayavardhan, you can start.
Hello everyone, I am Jayavardhan. So, first of all in this course we started with the need of simultaneous time frequency localization. We also looked at the idea of natural domain of a function. Specifically we looked at images and how they can be represented at a particular resolution, and how do we move from one resolution to a higher resolution using dyadic wavelets. Then this was the first time when half wavelets were introduced to capture the incremental information going from one resolution to another. Next we looked at the L2 norm and LP norm, in general LP norms of functions, and the need of finite L2 norm for piecewise constant representation of functions.
Very good, Jayavardhan. Now, who would like to take over from him? Who comes next? Yeah, so Pulkit is going to talk about the next part of the course.
Hello everyone, I am Pulkit Singh. First of all, we looked at how to represent a function using the piecewise linear constant representation. Then we went on to look at the hierarchical order of the ladder of subspaces, which Sir had taught us in the lecture. Then we went on ahead and studied the concept of a scaling function in the case of a Haar wavelet, and its applications were then introduced in the further lectures.
Very nice, Pulkit. Who would like to take over to talk about the next part? Saurabh. Saurabh is now going to take over.
Hi, I am Saurabh. The most interesting part I learnt in this course was how to see functions as a sequence. So, what I dealt with was to deal with functions as a sequence and then use them, use properties of sequences on them, like trying to find out norms and inner products for those.
So, what you are saying is you brought an equivalence between functions and sequences.
Yes.
And that made it interesting because there are a lot of things about sequences which are easier to deal with than functions inherently.
So,
yeah,
that
please
we
go
can
on.
extend it to higher dimensions using, we can go in higher dimensions using sequences. And the next thing we dealt with was touching upon Parseval's theorem. Yes, and this was all.
Very nice, Saurabh. So, who would like to take over from there? What was next? Yes, so Shivam is going to tell me what came next.
So, as Saurabh was saying that in this course we studied the equivalence between functions and sequences. So, what I feel is that this subject of wavelet is very closely related to the mathematical subject of what we study in basic mathematics, which is known as linear algebra. I also tried to add some of the additional information regarding some concepts from linear algebra like direct sum, and also we saw that when we introduce when we are able to define the concept of inner product on a particular set, which is a special set in itself like a vector space, then we can go ahead and define equalities like Parseval's theorem and so on, and we saw what is the importance of doing so. So, this was the part of the course which dealt with the functions. Now, to implement these functions, we went ahead and studied a system which is known as a filter bank. So, a filter bank, we studied that how mainly a filter bank
so,
is
Shivam,
a
you
system.
should tell us what a filter bank is. What is meant by a filter bank?
So, filter bank is basically a system, discrete time system, which takes some input and gives you some output. So, an input which is given to the filter bank is broken down into many components.
So, it has multiple, you have to be careful, it has multiple outputs. So,
yes, sir.
It's
So
one input, it has multiple
outputs and
or it has multiple inputs and one output.
Yes.
There are two possibilities, either the
yes,
analysis filter bank or
yes,
the,
yes.
go on. Yeah.
So, this part of the course was very interesting to me, and I would like to sir, ask you that from where if we go ahead and in the next module of this course, you in the first lecture you mentioned the concept of uncertainty principle. Sir, you can just tell few lines.
Yes, so in fact that's very good. So now this whole course is just the beginning of your study of wavelets and multirate systems. where we go from here is, of course, you have just sort of been introduced to what a filter bank is, how you could construct a filter bank which could then be iterated to lead to a scaling function on a wavelet, and then how a multi-resolution analysis can be created out of it. But what are the challenges? For example, why can't we be happy with the HAR multi-resolution analysis? After all, the HAR has all the nice and easy properties to understand, but the problem is we have not at all looked carefully at the frequency domain here. The whole idea, as I told you in the beginning, was to deal with the two domains at once. So, the frequency domain has actually been dealt with very poorly by the HAR wavelet or by the HAR MRE, and this is something we would now need to go on to understand if we wish to carry this subject further. What is the basic limitation, if any, which allows you to deal with the time and frequency domains together? How can you work best around these limitations that are there, and what is the design skill required to build multi-resolution analysis while keeping this limitation in mind? That is essentially what is meant by the uncertainty principle, and then so we will be in fact in a subsequent massive open online course where we would develop this subject much further. We would like to go into these issues. What are the basic limitations which come in when you want to deal with both the domains together? How do you address those limitations? How do you build systems around those, even if there are those limitations? And then how do you apply systems that deal with the time and frequency domains together in practical applications? So, this is where we would be, and I am very happy that all my teaching associates have closely interacted with all of you and built material for this course. We do hope all of you enjoyed this course, and we would be very happy if you asked us questions or if you suggested how we should continue to engage with all of you beyond this in a larger massive open online course. So, maybe we can have one concluding remark from my teaching associate Abhinav.
My name is Abhinav, and what I dealt with was extension of concept of Z transform to the discrete time frequency domain and the concept of ROC. So, we also had a look on the frequency response of analysis low pass and as well as the high pass filters.
Good, thank you Abhinav. So, this is where we left off, and in fact this is what would lead us to the next part of a massive open online course, right. So, with that then we come to the end of this discussion session, and we do hope once again that you enjoyed what we presented before you, and we look forward to engaging with all of you in future as well. Thank you so much.